Hey guys, and welcome to part 3 of our Data Lab Infrastructure series. Today we'll cover the layer 2 of our architecture, provisioning and configuring 3 Docker VMs and a GitLab VM. You'll learn how to set up GitLab as a container registry and how to run CI/CD jobs on a Docker host of your preference. I ended up using Cloud-Init instead of Packer to set it all up, but stick around and I'll tell you all about it. So first, let's begin by looking at our platform Terraform project, which is quite similar to the foundation project, and we started both last time. But this time we're going to focus on the main TF file, as well as these two new files for Docker provisioning and GitLab provisioning. So if we look at the main file, we'll find only one common resource between the two VMs, which is the downloading of the Ubuntu ISO for the cloud image, and then we've got our Docker Terraform file and our GitLab Terraform file. In both cases we define the VM configs that we want to tune as a local variable. In this case, because we're going to have multiple Docker VMs, this is an array. And for each instance we define the name, the VM ID, the number of CPU cores, the memory and the disk size. For the memory we've got two values. The dedicated value corresponds to the memory config on Proxmox, while the floating value corresponds to the balloon config on Proxmox or on the QEMU VM. This means that our VMs will have 6 gigs of RAM visible, and this is the maximum as well, and we'll define a minimum value for that RAM to be 2 gigs, so at least 2 gigs is dedicated, fully dedicated to this VM. And I know this naming convention that they use for this package is not that clear, but truth is that the 2 gigs are actually the dedicated RAM. It will always be available, while this is the maximum RAM and this is the visible value at all times. And so we define Docker GitLab, Docker shared and Docker apps. Then we create 3 passwords. We do that by using this count attribute. This means that this random password resource will be accessible via something like so you would do something like random password docker VM, and then you'll have an array, and 0 will correspond to the first element under this variable. So this would be the password for Docker GitLab, then 1 for Docker shared, and 2 for Docker apps, right? And this is how we use the same config to provision multiple resources on Terraform. Then we use this data provider to download the GPG key for the Docker apt repo, and we'll be using that in here below. And this is the main code where we are defining our Cloud-Init config, and we'll go through this in a minute. And then we have our VM definition, and as you see it also uses count, so this runs 3 times, 1 for each VM, and then we use this count index to access the config for the current VM that's being deployed. We also deploy the QEMU agent, which is required to manage ballooning, memory ballooning, as well as to just provide some information on the IP assigned to the machine and stuff like that. This over here try is if you are familiar with SQL's coalesce, this is kind of like that. So it tries to access this config. If it doesn't find any value, it will use 1 core. We did something similar over here for the memory. We only define one disk, and this disk will use the Ubuntu server image to boot up. Keep in mind that we are using a cloud image, which means that Cloud-Init is pre-installed on those images. Then we use the HTTP like last time, and we initialize with our Cloud-Init image. Notice as well that I added this lifecycle prevent destroy equals true. While you are working on your resources, you might comment this out or set it to false or not at all, right? But this is important once you deploy the infrastructure and you want to make some change, like changing the number of cores on the CPU or increasing the available RAM while decreasing it somewhere else. If by mistake you edit something that would require you to destroy the VM, this will avoid that Terraform runs during apply, and you can, fix whatever you need to fix instead of destroying your VM and losing everything that's been deployed there. So this is a nice safeguard for you to avoid, losing everything just while changing the RAM or something like that. And so for GitLab we have a similar config, but this is not an array, it's just the config for one single machine. We set a password for the VM, for the VM's root account, as well as for the root user of GitLab that we are going to use. And then we have a similar config for Cloud-Init. We'll go through it in a minute. And also we have a similar config for the VM. We just don't have the count over here because it's only a single instance. Also, just some quick comments on why we dropped Packer. We had planned to use Packer before. I think it's just overkill to have to build an image using Packer to deploy it 3 times. I tested it with Cloud-Init. The config is not that complex and it runs quite quickly. So there really wasn't any justification to use Packer here. Even deploying 3 separate Docker VMs is a bit questionable, and I might downsize in the future. So there are some pros, like better isolation or dedicated resource allocation. So you make sure that you can, destroy the Docker VM for your apps and just recreate it without messing with your shared services, for instance. And you always know that you'll have some resources allocated for your apps. These will not compete with other resources. Although I believe Docker would be able to manage this without much hassle anyway. So in the future I might consider merging Docker apps and Docker shared into one instance. And regarding GitLab, I might also run GitLab runners for CI/CD within the same VM as GitLab, while for that particular case it makes more sense to keep things separate, because you might want to work on your repos, commit and push efficiently without having any load on the system that's being used for one of your CI/CD tasks or jobs. But I will look into this in the future, and I might downsize. I also considered using Git instead of GitLab. GitLab is Ruby based and it's a bit complex to set up. Documentation is not the best. And also if you run GitLab Rails console, it takes quite a while just to start. And Git is Go based, so this should be fairly more efficient than GitLab. It also provides a container registry, and it has its own act runner for CI/CD. that can run on a remote Docker host as well, which is what we want to do here. You just set it by installing Docker locally and setting the context to your remote machine. So if we decide to simplify the setup, it might make sense to drop Docker GitLab as well and just run everything on the GitLab machine, but we'll see what we'll do. And for now we are going to keep this separate, and this is what I'm going to teach you how to deploy here. It's not that different anyway. You will just drop the count on your Terraform project and deploy a single VM instead. So now let's talk about Cloud-Init. First, a quick intro. This is made by Canonical, but it was adopted by the community, and it's built for customizing cloud images with user data and system defaults, and it's usually pre-installed on cloud images. It supports most of the popular Linux distros and even FreeBSD. And it is quite lightweight and minimal compared to something like Ansible, although it's designed to run just once. So idempotency is not a factor. As you know, for Ansible you can run the same playbook multiple times and it should not change its outcome regardless of which state it runs from. But for Cloud-Init, you just don't have to worry about it. It's meant to run once and that's it. So for Docker, what we are going to do here, our goal is to have 3 Docker VMs, each of them configured in a similar way, and we want to have a Docker host with TCP listening so that we can have remote access to each VM. And so this is how a Cloud-Init config looks like. It is a YAML file. We are defining this using a Proxmox virtual environment file, which will be dropped into the snippets storage location, and from there it can be used by our VM when provisioning it. And so in here you can set your host name. We are using the name of the VM that we defined on the local variable. We can set its root password, and we can do this change password and set expired to false. Otherwise, when you first log into the machine, it will ask you to change your password, because this is just a home lab. We don't need to do that. We also need to enable SSH password authentication for this to work, because otherwise we'll only be able to sign in using, or to log in using, an SSH key. Then we have a few features from Cloud-Init, like APT, which lets you define your APT sources. In here we are defining a Docker source, so this will translate into a Docker list inside your VM. And the source will be the source for our Docker repo. And then we are essentially pasting the key over here by using this data resource. This will download the resource, and then we can, or download the key, then we can access that key via response body, the response body output. Jump will remove the last new line, and indent will indent everything except the first line, 8 spaces, so it will align perfectly over here. If you don't do this, this will not work, by the way. Then we've got this package update and package upgrade, which is just a general way to say that your system should run apt update and upgrade. Depending on the system, of course, each will have its own command. Then we want these packages installed. We install, like I said, the guest agent for QEMU. This is what agent equals true means. We are running this package, okay, and this will be required. And we are also installing Docker CE, which is the package from this repo over here. Then for Cloud-Init, we also have this write files option, and each this is an array, and each element will be a file. So in here, to configure Docker, we are writing two files. First, we are writing this override.conf file for systemd, and we want to override our exec start particularly. So this is done twice, because if we don't do this, any options that you add here will be added to the existing config. So first we clear the config, and then we set it to dockerd without any arguments, which means that when it runs, it will use the default config under etc docker daemon JSON. And this is why we are creating this over here as well. And for the content, we just reproduce the fd, which is the Unix sockets, as well as containerd, exactly as they were run with arguments on the original config. And then we add a TCP listening on 2375, which is the default, I believe. And so finally, we get a run cmd, where we can run whatever commands we decide, and we enable and start the QEMU guest agent. We run this netplan apply so that the host name gets broadcast to your DHCP. Otherwise, you'll have to know the IP if you want to SSH into the machine. And this will only broadcast it for the first time after that login. This is why we do it here explicitly. Then we add the Docker group to the Ubuntu user, so we can run Docker commands if we sign in directly using the Ubuntu user. And we reboot, because most of the times when you update your packages for the first time, you are asked by Ubuntu to reboot. So we do it anyway. That way, once you SSH into the machine, and you have to wait for a while after Terraform Apply runs, because Cloud-Init will be running on the background. But once you do it, you'll have everything, clean and ready for using. And now let's take a look at how to configure GitLab as well. So similarly, we've got our Cloud-Init config. This is exactly what we did before for Docker as well. We set a hostname and a password. We set it not to expire. SSH will let you log in using a password. Update and upgrade all packages. Install the agent. And also install curl. I believe it's available by default, but anyway, it's better to do it explicitly. And now we are going to start to our actual GitLab configuration. So the best way to do this is a mix of editing GitLab Ruby, this RB file, and running GitLab Rails console with some particular options. So first we write this etc GitLab RB file, where we set the external URL to use the same host as our VM name, which is also the one that's broadcast to the DHCP. We set the initial root password as well. And now we enable our registry and set an external URL for the registry. Use port 5050 for this on the same host as our GitLab. And then we need to enable the registry's database. This means that the default instance for Postgres for GitLab is being used for this as well. And we set our storage to be our min.io instance that we had deployed on our foundation layer on the previous video. And so we just set all of these with Terraform variables. Most of these have a default value, with the exception of S3 access key and secret key. And we set a particular bucket for this that we had to create because we didn't have that bucket before. We call it GitLab, and I can quickly show it to you as well. You'll see that we have these buckets from the previous video, and now we created this new GitLab bucket where our Docker image layers will live. Next, we also enable the guest agent. We run net apply to broadcast the host, and then we add the repo for GitLab. You can conveniently run the script over here, and we can install all the command lines for GitLab to run using apt install gitlab-ci. But then this won't give you a running instance of GitLab unless you set up some environment variables over here, which we opted not to do because we are depending directly on the configuration. And so we just run gitlab-ci.yaml reconfigure, and this will run for a while and will install everything that is required for your GitLab to run. Soon after the initial steps run, you'll be able to access GitLab on port 80, so just http GitLab and you'll find your instance, and it will show you a screen saying that GitLab is starting. It will take a while, and once that is done, we can run GitLab Rails console and set a few settings that you couldn't with the GitLab RB file. We disable sign up by default because this is a private instance. It will be, all accounts will be managed by us using the root account. And we also disable some annoyances like version checking or you know, anything that tracks your information and sends metrics to GitLab. We also disable the what's new variant as we want just a clean install for GitLab. Then we also install the repo for GitLab Runner, which is a separate repo, and we install our GitLab Runner. While GitLab Runner will run on the same machine as GitLab, the actual work, the actual jobs will be run on Docker. And this is how you set that up. So you run GitLab Runner register with non-interactive. You set the URL for your GitLab instance. You are able to get a registration token. You can do this if you are doing this manually, you can get it via the UI, but because we are not doing this manually, we can actually use GitLab Rails Runner to obtain this token, and it's something like accessing application setting current runner's registration token. We'll print it to the standard output and will be used on this argument. And then we set up our executor. In our case, we want to use Docker. The base image will be Ubuntu latest. We are going to call this runner Ubuntu latest runner. This will be a shared runner for all your repos on your GitLab instance. And we assign a few tags just for information value. This is a Docker, it's running remotely, and it's an Ubuntu distro. Then we have this run untagged set to true, and we set our Docker host to the same host as the one configured on the Docker 0 variable. You might notice that local is available here. This Docker variable is available here. So every local variable within your project is available on any context. So you might split them up, but they are still available elsewhere. And this is how we can access this. And then we reboot our machine. And that's pretty much it. You should have to wait a while, but you'll get a GitLab instance running. And so now let's Terraform apply everything and look at how this, how the status of everything will look. So we start from a min.io instance. That's pretty much what we have here, and we got this backups storage that we are not using. And so now let's go into our data lab dir under infra platform, and let's run Terraform plan first to check what it's going to do. These will be the outputs that it will share with you. And so we are creating a password for GitLab VM and GitLab root, and we are creating a bunch of other passwords for Docker as well. You'll find your GitLab instance is set here, and you'll find that your Docker instance number 2 is set here, and we'll have the same for the other instances as well for Docker. We've got our configs, and okay, it looks good. So let's run Terraform Apply with auto approve now, and it's running. And now let's switch into Proxmox so we can take a look at what is happening over here. In a second we should see the VMs popping up, and we can check the logs, and it's currently downloading Ubuntu. And so Ubuntu will be downloaded onto local ISO images. It will appear over here once it's downloaded. As you can see, we've got Ubuntu here. Our VMs are being created. They will start, and Cloud-Init will begin to run. Let's check back our terminal as well. As you can see, it's still running, but Terraform will finish before the whole procedure is done, because then it will move to Cloud-Init. And I'll also show you how to track the status of Cloud-Init. We'll do it for the GitLab VM because that's the one that takes longer to set up. Let's first wait for this to finish. And we're done. And let's try to capture the process, the ongoing process. So let's first copy the password for our GitLab VM, and we can sign in using this approach. And now that we are here, as you can see, the system hasn't been restarted yet. We can run cloud-init status-l, and you'll see that it is still running. If you want to track the progress, you can tail var log cloud-init output, and this will show you what is being currently run. And we are on the run CMD stage right now, and we can, track everything that's being done here. This is the output, but you can also look at the regular log if we want to, and this will be more on the side of the Cloud-Init, what Cloud-Init is trying to do. But let's for now track this and wait for a minute there, at least until GitLab is installed and running. What we'll do next is try to access our GitLab instance over here. So it will be under HTTP GitLab. You can see there's nothing here yet. We'll get back to it in a minute. And let's quickly check to see. And as you can see, it is already waiting for GitLab to boot. So after the initial stages of GitLab CLI reconfigure, you'll get this screen, and eventually GitLab will load here. You don't need to refresh it because it loads automatically. And as you can see, there are several steps towards deploying GitLab. Imagine if you had to do this without the help of GitLab-ci reconfigure. This is a much easier approach to deployment. And we're back. So now that everything has run, let's go get our GitLab root password. Let's log in as root. There we go. We've got our GitLab instance. Now we can go into admin and we can check that our container registry has been configured, and we've got one instance runner called Ubuntu latest runner deployed as well. Let's create a user account. Let's call it GitLab Tech TV. GitLab Tech TV. You cannot set a password and we don't have SMTP set up, but we can create the user and then we can edit it, and now you can set the password as you would like. There we go. Let's now sign in with the new user. It will ask you to set up a new password, and you can do so, but I'm just going to keep the same one. And now let's create a project. It can be a blank project, private. Let's add a README. We can select the namespace because you can have several. Let's call it just sandbox. Okay. And now it's asking you to add SSH keys, so let's take care of that. So if we go back into the terminal, let's create a key called GitLab, and let's copy that key. Add this SSH key, paste the key here, let's give it a name. We can remove the expiration date so this key doesn't expire, and now we should be able to access this repo. So we should be able to clone the repo. Okay, this has happened because I probably have to add this key into my keychain. And there we go. Let's go into this sandbox. And this is what we're going to use to test our full deployment, including Docker as well. Let's first test our Docker deployments to make sure they are running correctly. And the way you can do that is you can just ls your context. We are currently using the default context, and let's just create a new context called Docker GitLab. And we are going to use this host name for it. Okay. And now we need to switch our context. Let me check. So context use Docker GitLab. Okay, now docker ps, and we should be looking at our instance. We can even run maybe hello world, I believe. And here we are. If we switch back to our local context, so on default, and we ps, we only see our local containers. So this seems to have worked. Just out of curiosity, I'm using something called Starship, which is a prompt customization script made in Rust, and this is what provides the context name in your prompt. So if we go and run docker context use default, nothing will show, and this is the one that is ignored. So if you see this, you are running docker locally. You might also have other local contexts like desktop Linux, which will sometimes show, sometimes be hidden. Oh, this could be probably hidden, but this is quite helpful for you to be able to track all this stuff. In Terraform you also can have multiple projects, and this will also help you track those projects. If you are working on AWS or GCP, other utilities will show up here, like the AWS profile that is currently active and stuff like that. So it might be interesting to check out Starfish, and this is just a kind of a side note, or Starship rather. You can check it out over here, and everything that can be configured will be listed here. For instance, we were looking at docker context right now, and these are the options. So it by default it detects these files, and it will be shown if these files are detected. But I have only with file set to false, so it will show anywhere, and you can configure other details as well, like the style or the format. So now let's create a Docker file on our newly created repo. Let's just add Ubuntu latest and a command to print hello GitLab container registry. Okay, let's save this. Now we are going to test whether we can push to the container registry, and the first thing that we need to do is to log into this registry. So it should be on port 5050. Our username, we can create an optional key for this, but I'm going to use the password, which is perfectly fine as well. And as you can see, it's trying to access HTTPS. I knew this error would happen, and so what we have to do to fix this is go into Docker desktop or your etc docker daemon JSON. Let me just, because I'm running on Windows here, let me just go directly into Docker desktop. And here we are. If we go in here into settings and go into Docker engine, then we add a new setting called insecure registries, and then an array of hosts. And let's apply and restart. Also, let's make sure that we are on the default context. And now let's again try to log into GitLab. And there we go, we are logged in. As I was running before, I was on a different context, so the login would have failed anyway because the config I changed was locally. In order for that to work on the Docker GitLab VM, I would need to edit that configuration on under etc docker daemon JSON. And now we can, let's first add this Docker file. And now let's config the name and email for this repo. Let's commit Docker file and let's push. So this confirms that our GitLab is working as expected. So we can use the repos as expected. Let's go just into the repo and check that Docker file is here. And as you can see, it has been added. And now let's build this image and let's call it test. I like to build it with a local name and then add a tag afterward. And so your tag should be, you can use the existing tag as your source, and then the new tag will be the container registry for GitLab / your username on GitLab / your repo, and then the name of your image and version. And now we can Docker push. As you can see, the container registry seems to be working. Let's go into GitLab again and let's go into deploy container registry to check out whether it's here. And as you can see, the image has been pushed. We can also go into min.io and refresh this GitLab bucket to find that the registry has been added over here, rather the layers for the image. And so this part seems to be working. So next we'll want to test our CI/CD runner. So let's create a gitlab-ci.yaml file. And in here I'm going to create the runner info job, which is a script that we'll call ls CPU. So we know information about the CPU of the runner. It will show information about the free memory, information about disk space usage, and it will print the values for these two variables that we still need to define. Okay, so for now we can add our GitLab. Well, let's not commit it. Alright, let's not push it. Okay, rather than pushing it right now because it will trigger the job and we haven't set the variables yet, let's first go into GitLab and let's set those two variables, some user and some passwords. So this should be under settings, CI/CD. You go in here into variables and scroll down, you'll find this table. You can add variable here. Let's set the first one to visible. So our key will be some user. Let's call it user1 for the value. And now let's also add a masked and hidden variable. And let's call it some pass and password 123 or something like that. This will be hidden. On the UI, as you can see, some user is still hidden, but you can copy the value. But for some pass you cannot, and if you try to edit this, you won't have access to the value anymore. So now we can finally push this. Going to build jobs. We'll find that there is now a job that has passed, which means it ran. And we go into runner info, we'll find the log for this executor. As you can see, after loading the initial image, loading the repo, it ran the ls CPU command, showing one core. That's what we have assigned here. and then we see that we have 6 gigs of RAM available. We see that we have about 100 gigs of disk space, and then we print the sum user variable, which shows user 1, and the sum pass variable is masked as required, although we have access to that value for our scripts. And that's how you do basic CI/CD on GitLab on your own instance that you installed. Everything is running under GitLab, but all our runners for CI/CD run on Docker GitLab. In fact, if you go into the command line and let's, for instance, try to show this, we go in here and edit this. Let's add some other command, just with an additional echo. Let's make sure that we are on the Docker GitLab context so we can inspect the containers. And now let's commit the CI, add command, let's push it, and let's quickly run watch docker ps. And as you can see, the runner was just, and this was very quick, but the runner did just run. I don't know if we have access to those, but no, they get deleted right afterward. And as you can see, we are actually using our external Docker VM, our external Docker host, to run our CI/CD jobs. I hope you found this interesting so far. And now that we're done with the infra for our platform, all that remains is deploying our actual data stack. And this is what we'll do next time, using Docker Compose and a CI/CD job for automation. As usual, I'll keep adding these videos to the Data Lab Infra playlist, but until then, make sure to read this week's blog post at datalabtechtv.com. Follow the channel on Blue Sky for updates, and join Discord if you have any questions. Don't forget to drop a like and subscribe for all things data.